Docker, 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 Docker. It's been a while since we've gotten back to the namesake of this channel and ran some questionable commands, and today's victim is Docker, or more specifically, Docker in Docker. So if you are in an environment such as Kubernetes, where you're running your CI/CD and you need to be able to build a Docker container, but you're inside of a Docker container, you use Docker in Docker. The logo for Docker is, of course, a whale, and there is effectively then a whale inside of a whale, which means that the first thing that we need is to rename Docker in Docker to Jonah. So first things first, I'm already in the questionable commands directory here. I'm on the main branch. Let's create a new Docker file specifically for Jonah. I'm going to split to a new tab here, and I am going to cd up a level. Let's make dir Jonah dind, or Docker in Docker. Then we'll cd into our new directory. We'll go ahead and touch a Docker file, and we'll go ahead and open VS Code. We'll go ahead and open up our Docker file here, and all we're really doing is renaming Docker in Docker to Jonah. All we really need in this instance is from Docker dind. Now we can build and push this, and we'll have Docker in Docker renamed to Jonah. I've already done this. I already have this published, so we'll go ahead and leverage that. And I'm already done here, so I'm going to close this out. I'm going to tell you about the goal of today's video, which is to recursively go down into Docker in Docker as far down as we can go. So Docker and Docker and Docker and Docker and Docker. It's Docker all the way down. And we're going to see what happens. We're going to see how it breaks. I think I already know how it's going to break, but it'll be interesting to find out if I'm right. While doing research for this video, I learned the word quine. I'm not sure if that's the correct pronunciation. If you know better than I do, go ahead and leave it in a comment down below and let me know how to say it. But effectively, quine is an application where part of its output is the application. Yes, the little AI answer here says, in computing, a quine is a program that takes no input and outputs a copy of its own source code, named after the logician Willard Van Orman Quine. So we'll go ahead and switch back to our editor here. We're now done with our Jonah Docker in the Docker. Like I said, I already built and published that. So if you need Docker in Docker for your own project, well, now you can use Jonah instead and be a little silly. I don't know. There's no value. So let's go ahead and follow our pattern here. Let's make a new directory. It is 24th of June, 2026. This is episode 0x004. And we'll name this Docker Inception. And of course, it helps to have the make dir command in front of it. All right. With that done, let's cd into it. And I know I'm going to need a Docker file, so touch Docker file. And the plan might change, but I think right now what I want is a file that is a script that gets run as an entry point to Docker. So I'm going to touch, and let's be a little cheeky with the name, runme.sh. All right, now that we've got everything scaffolded that I think I'll need, I'll go ahead and fire up VS Code. And in the Docker file, I know I want to use a Docker image I just created that is renamed Docker in Docker, renamed to Jonah. Okay, so from dev.dol/Jonah, we'll go ahead and just use latest. And because we want to run Docker in Docker inside of Docker in Docker, did I say that right? Someone tell me if I said that right. Then we are actually going to need our own Docker file inside of the Docker image. So first thing is caps lock, copy Docker file to Docker file. And then I don't know what's going to be in it yet, but I know that I also want the entry point file. So we're also going to copy runme.sh to runme.sh. And just while I'm thinking about it, let's go ahead and change the permissions on the runme file to make it executable. So chmod, let's do 755 runme. And now, of course, we need to set our entry point, entry point, and I don't know what, if any, parameters we'll want to send to it. So for now, I'll just do ./runme.sh. And if I'm not mistaken, I'll need to run something else here, but this is a good starting point for now. So let's, this should get us the basics, because inside of runme, well, first let's do shebang, bin bash, or actually Docker and Docker may not have bash. So let's do sh. And I already know that we need to build the Docker file that is the Docker file we just made. That should already be in our container image along with the runme shell script. So we can say docker build dot. Okay, and then once we've built the Docker image that is the same as our current Docker image, then I need to give it some kind of tag to make it easy to reference. So let's do -t and we'll call it Inception. Did the whale have a name in the tale of Jonah? In the tale of Jonah, did the whale have a name? No, the creature does not have a name. All right. Oh, but literally translates to great fish. I know what to do. On Inception. Fishy. So then now that I've settled on a tag name here, let's add a comment here. Build the Docker image that's identical to the Docker image that we are currently in. All right, and then once we've built the Docker image, we need to complete the recursion by running the Docker image. So Docker run, I think we're gonna need -- privileged here, but let's try it without first. So we'll say Docker run fishy. Let's add a comment. Complete the recursion, yes, by running the new Docker image. So let's save this, make sure I've got Docker running here, and we'll jump back to the console. Clear out the screen and Docker build .-t. And what is the parent fish? What's the biggest fish of all the fish? Let's just call it whale. And while we wait for this to build, why don't I tell you about today's sponsor? I don't have a sponsor. So our new image is built. So let's actually run it. Docker run whale. Yes, the Docker daemon is running. Cannot connect to the Docker daemon. Is Docker daemon running? Oh, you know what? I think I almost tricked myself. Let's see if we still get this message when I do -d for detached. Docker run -d. No message. Docker ps. ps-a. Yes. Okay. So this message is actually coming from inside. It's coming from inside the whale. All right. So this message is coming from the Docker instance inside of Docker and Docker container. This is getting very confusing to talk about very quickly. I trust you understand what I mean. So we need to go back to our runme script, and we're going to have to wait for Docker to start up before we can actually run the build. The way I want to do this is I want to wait for the port number to become in use inside the Docker and Docker container, because once that port number is in use, Docker is up and running. We're already inside of runme. Let me find out what port number Docker and Docker uses. Or better yet, let's actually spin up an instance of Jonah. So Docker run, and I want to be able to poke around inside of the container. So let's do -d for detached, and it'll be dev-dol : JONAH. Oh, right. It's dev-dol /Jonah : latest. And it was already pulled. I was just using the wrong run command. So let's change this to a / and then latest. There we go. And of course it quit right away because I didn't give it any parameters of what to actually run. So let's do it again, except for now, let's tail-f dev null. Dev dull dev null. Docker ps. There it is. So docker exec-it, and we want to run, we don't know if bash is there, so bin sh. So now we need to figure out how to tell if Docker is running. Oh, not Docker ps. So ps and then grep for Docker. And that didn't give me anything. That surprises me. Let's see what happens when we do a Docker ps. So is Docker not running? Okay, so what I did is I typed Docker. I'll just do it again here. So I typed Docker, and to complete the command, I hit double tab. And here we are with this Docker D entry point. I want to take a look at this. I want to know where it is, first of all. So where is, let's try which. So use your local bin. Let's take a look at the file. I have a feeling I'm not going to care about a lot of this. All right, so whatever is going on in this file, and I don't think I much care, this is going to be coming from the Docker file for Docker and Docker. Let's go look at the Docker file for Docker and Docker and see what's going on. See if and how this script is being invoked, and maybe it'll offer some clues about whether or not we need to do this as well. All right, this appears to be the Docker file for Docker and Docker. So what are we doing inside of here? Don't need to wait for Docker to come up. I just need to run this. Maybe I need to do both. So let's set this aside for a moment. So really an entry point should be running everything that we've been passed anyway. Normally you'd put that down here at the bottom because this would all be setup stuff. But in our instance, the setup is starting Docker. So I think we actually want to put it at the top. So we'll do exec, $@. I'll go ahead and put it in quotes. I think this exec is going to be blocking. Let's take another look at the shells, at what's going on here, and then possibly the shell script. So yes, we'll have to look at Docker D entry point. Let's go down to the bottom. Yes. So because it's recursive, I think ultimately it's going to end up being blocking. So let's go back to here, and we'll go ahead and put an ampersand here so that we're no longer blocking. This is going to wait for execution to end. And then without the ampersand here, this is going to wait for execution to end. So we're never going to get to the Docker build step. That does mean that we need to wait for the Docker service to become up and ready if this Docker D entry point is doing what I think it's doing. So we do need to detect if Docker D is running before we do any of this other stuff, which means I killed and got rid of our container instance, our running container too soon. So let's go ahead and pull it again. And we'll run it again. And Docker exec-it. And then let's see if we've got bash. No bash. So sh. So effectively that Docker D entry point file script is running this. And because it's blocking, it's preventing the container from completing its execution, which means it will be blocking, which means I definitely need the ampersand here. Let's start with just a PS and search grep for Docker, and got nothing. So let's go ahead and see everything that's running. No dice there. Let's see what we find with netstat. And I like NAP as my options. So let's do Docker D entry point, and I'll say echo high. Now what do we get? Looks the same. Oh, well, I run it on its own and I get a permission denied. And this is what I was getting to with the -- privileged flag. So let's exit out of here. Let's kill the container we've got. We're going to run again, and we're going to pass in -- privileged. PGED. Okay. Exec into ecstatic colon. Then sh. And Docker D entry point. Ah, yes. Very different. And again, it is blocking. So if I control C, it's going to kill Docker. Stopping, yes. Okay, so we definitely need the ampersand, and we definitely need to check. Okay, so let's stick the ampersand here. I'm actually going to redirect IO. And redirect standard error as well. I'll just redirect that to 1. Then I could do PS. Oh, what happened? Now we can see Docker running. This is Docker init. Does that go away after a sec? It's still here. The problem is just because I see it running doesn't mean it's ready to accept connections yet. So I think probably the safer bet is to see if the service is listening on a port or a Unix socket yet. Okay, it's probably a Unix socket actually. So the -n API I ran earlier, not going to work. I'm going to need an LP, I think. So netstat -nlp and all pipe grep -i docker. All right, lots of things. Excellent. And you know what? This first one looks perfect because we can key off of listen and we can see that it's Docker. Yeah, I don't know that this is the best one, but it's the first one and it's easy to query on. So we are going to do netstat -nlp pipe grep, and we want to grep for case sensitive all caps listen, LISTEN. And then we want to grep for Docker D, and that is the end of the line. So let's see what we get. There it is. And let's make sure that our output is going to be easy to test on. And let's give -o, which is only going to give a Docker D that is at the end of the line, or very literally this part of the output. And there it is. Okay, so we know what we can test on. So let's go back to here into the runme.sh script. So now that we've started Docker up with that Docker entry point command, we can do a new variable called Docker up, and we'll set it to an empty string. And then while $Docker up, oh, I was going to say is empty. And yes, that works because we're grepping for exactly Docker D. So while Docker up is empty, that's what the -z means. Do done, just to get that out of the way. I don't know. We'll sleep for half a second. There's no guarantee that sleep inside of this container honors fractional seconds. So we'll sleep 1 second. Then we'll set Docker up equals the output of the command we figured out earlier. I'm worried about this $sign here. Let's jump back. Yes, we're still here. So what I'll do is I'll test it and just make sure there's no quirks with having a single quote around Docker D. Yes, good. Let's add single quotes around our grep for Docker D $sign. And if we end up in an infinite loop here for some reason, I want to know about it. So let's go ahead and echo waiting for a nibble. Nibble from a fish. Okay, and I think we are all set here. Let's add in some comments. So invoke Docker D entry point as passed by the dind container. I feel like that's vaguely inaccurate, but accurate enough for the purposes of this. Let's also mention that Docker D entry point is blocking. So invoke with an ampersand and test for Docker being up. And here we are waiting for Docker to start. All right, let's give it a shot. Start by cleaning up. Docker rm these two. And we'll go ahead and build. So docker build -t whale. It built, so docker images. And we've got whale here, so docker run whale. All right, now the question is, are we infinite looping or are we recursing? So let's go ahead and cancel this. Docker ps-a. We'll go ahead and make a couple modifications so that we can see what's going on. So just to quickly see if we're infinite looping, I think I'm just going to output the host name here. So I should just say $ capital, all caps, host name. And I think that'll be the same as the container name, but we'll find out. So let's build this. We'll see if that changes. Build. Seemed a little quick, but whatever. So it's not the container name, but at least it's something informational, and it is not changing. So let's cancel this. Go back to here. What could be wrong? Yeah, because we should see the output of this docker build command if we're making it to here. Maybe Docker is taking longer to start up than I think it should. Let's implement a counter here. So we're going to say count equals 0. Instead of echoing the host name, we'll echo count. And we'll say let count equal $count plus 1. All right, let's build that. And then we'll run it. And then hopefully, eventually, this counter will reset to 0. Okay, it definitely should have started by now, so we need to figure out what's going wrong with our Docker service start detection. Let's also echo our Docker up. I don't think this is going to reveal anything, but let's go ahead and build and run it again. Okay, let's cancel that. Let's go ahead and show the output of our Docker service detection command by just running it a second time here, but maybe without this last grep. I'm just going to comment it out. So let's go ahead and build that and run it. Let's go ahead and put a PS here as well, just to okay, yeah, so PS is showing it. So that means nothing is ever listening. So maybe I really am just not giving it enough time to start up. So tired of seeing the output of PS, so let's comment that out. Here we go. Since I'm going to give this more than 1 minute this time, I am going to go back to here. So it must be this $@ is not what I think it is. So let's echo that. Build it. Run it. Yeah, so it was blank up here. And I thought dockerd entry point would be passed in, but perhaps not. So let's try running it directly. In which case we don't care about that anymore. Build it. Run it. Ah. I wonder if the whole issue is because I'm not using the privileged flag. So docker run -- just copy it out from my previous. Yeah. So now we're inside Docker and Docker, and we're building the new one. And now we're inside another Docker and Docker, and we're going to be building a new one, hopefully. We'll see. I think I'm going to need the privileged flag again. I think it's going to get stuck. Oh no, can I not Control C out of this? Okay, good. So let's see. We've learned that I need the privileged flag here. So let's add privileged again. I don't think that's going to fully fix it, but let's build and run again and just see if we get any behavior differences now. Oh, no, we're building a second image. Was that it? Was it just the privileged flag this whole time? Oh, yeah. Now we're building a third image. Maybe I was right. Hold on. Let's quit out of here. Let's change this back to $@. Go ahead and comment out this so I don't have to reproduce it. Let's see what happens. Build, run. Okay, no, this is much too long, but I'm wondering if yes, okay. So here's the issue. Let's specify caps lock, please. CMD. Put Docker D entry point here. Because my entry point script should now be reading the command here. This should be getting passed to run me effectively. And we're building a second one. I'm going to wait for a third one just to be sure. And there we are. Great. Okay. So let's go ahead and stop this. And the next step is to see how far down this rabbit hole will build itself, dig itself. My favorite word for rabbit hole is a warren. Did you know that there's a literal word for rabbit hole? I didn't. I had to look it up. I'm like, what the hell's a warren? It's a rabbit hole. So let's see how deep this warren goes. But I don't want to monopolize the computer that I use for everyday stuff for this. It'd probably be fine, but I don't really want to risk doing this on a VM because then we'll have abstraction layers inside of abstraction layers, and who knows what kind of additional wonkiness might happen as a result of that. So I need to dig out a computer that I can run this on. But before I do that, I want to make some predictions. One of my predictions, I've been told that Docker and Docker is actually just communicating with Docker on the host system. So it's not really Docker and Docker. It's more like there's some craziness going on with port forwarding down into the container so they can talk to Docker on the host system. I'm not sure if I believe that. It makes sense from a technical standpoint, but I have not ever observed any of that kind of behavior on an actual host system. So prediction one is that once we get this up and running on real hardware, I'll do a Docker PS and I'll keep seeing the list of Docker instances grow. But again, I have not observed that behavior, so I don't think I'm going to see that. Now, my next prediction is that Docker is effectively just an abstraction layer around the host system. So if you go to the right directory, you'll actually discover that the file system inside of the container is just being mapped to a real file system on the host system, which means if you can find that directory, you can traverse it all the way down, which means that the failure mode is a little surprising. I think we might run out of inodes on the file system. Now, another failure mode that I think we might encounter is that way before we run out of inodes, and I think we're going to run out of inodes first, that will eat up all the memory on the host. And the final failure mode that we might encounter is that the amount of CPU we have available on a system is less for Docker than the amount of memory available that the Docker containers demand, which means we'll just chew up the CPU, have it at 100%. So we've got multiple things we need to monitor before we can actually fire this thing up. We need to keep track of the number of Docker instances running. We need to keep track of the depth in which we are at inside of the Docker images. So we've got Docker and Docker and Docker and Docker and Docker. Like, we need to know what that number, what that depth is of Dockers inside of Dockers. We need to keep track of our system's memory usage. And I think trying to keep track of that at every Docker layer is going to be too difficult. So skipping that, I think that introduces new problems that are not worth facing at the moment. And then the next thing to monitor is the host CPU usage. And again, ideally, we monitor that at every layer inside of our Docker and Docker and Docker. But again, logistically, I don't think that's practical. So now that we've got our Docker nesting doll contraption working, we need to start thinking about how to monitor these things. Okay, so I've been thinking about it, and I think this is going to be my guinea pig for our Docker and Docker and Docker and Docker. My light burned out. What did that happen? There we go. So what this is a mini PC with an N100 Intel CPU. I'm not sure how much RAM it's got, but for our purposes, we don't need a lot of horsepower. We just need something that will die an untimely death. You can tell from the label on it that this used to be part of a Kubernetes cluster I was running. And the reason why I had picked this was because it was cheap, it was reasonably good, and it had 2 network ports. But I've since virtualized my Kubernetes cluster, so now we get to torture it. So I'll go ahead and reinstall Linux on this, and I'll bring you back. Alrighty, I've got Linux and I've got Docker installed on that mini PC. But before we copy the code over and get started on running, we need a monitoring strategy. So we need to monitor IOPS, we need to monitor inodes, we need to monitor CPU usage and memory usage, and then hopefully I can screen capture the device as well. I've got a plan for that, because if I'm right and we're going to run out of inodes and or disk space, the video file from a screen recording would just get corrupted. So that means I need to set up my capture rig to pull video from the mini PC. I'm pointing at it. You can't see me. Anyway. So before we go any further, let's make it so the only output that is from running the Docker image is how many Docker instances deep we are. How many times Docker is in Docker is in Docker is in Docker, yada, yada. Let's go back to the code here. And inside of run me, we need to suppress a lot of this output. So we don't need count anymore. And we don't want these echoes. We don't need our debugging command. We don't want to see the output of Docker build. We'll redirect that to dev null and redirect standard error to standard out. Yes, Docker run will also have output of the container name. So let's redirect that as well. So now we need to know how deep we've gotten into our Warren. So let's set up a environment variable that is an integer to tell us our current Docker in Docker image depth. And while we're here, let's clean this up real quick. Okay, so in our Docker file, I think I'm going to specify a new arg. We'll say arg depth equals 0. And actually, let's make this capitalized. And I think I'm going to tweak the name here as well. So dind depth. Okay, and with our initial Docker and Docker depth value seeded, we can go back to runme.sh. And at the very top here, we can say echo, and I'll go ahead and put a quote here. I'm going to leave the variable name without a $sign in front of it, just to add a little bit of clarity for what's going on. And then we will go ahead and echo out the variable as well. And now let's increment that value. So let Docker and Docker depth equals $Docker and Docker depth plus 1. And then down here in the build, we'll go ahead and add a -- build arg, and then Docker and Docker depth equals our new Docker and Docker depth value. And if I've done this right, every single time that we kick off a new instance of the Docker container, we should print out an incremented value. So let's go ahead and test that out. Go back to our shell here, and we'll build it, and we'll run it. And something with our redirection's gone wrong because we are seeing lots of extra stuff. Connection reset by peer. What did I miss? I think perhaps what I missed was, yes, I did. Okay. env Docker and Docker depth equals Docker and Docker depth. And this needs the curly braces in it. Let's give that a shot. I think there's still something else wrong, but one thing at a time. Build it. Run it. We got our 0. That's a good start. But somewhere we're missing some IO redirection because we have all this extra stuff being spat out. So what's invoking this? For good measure, let's redirect this. But this is not in the cause of our output. Let's see. The issue is this exec. So we'll copy our redirect statement. We'll paste it up here and cancel this out. We'll build it. We'll run it. There we go. But I do think something else has gone wrong because I really think we should have reached depth 1 by now. Is our depth locked up in the parent container? So let's split my view here really quick. We will Docker ps. The newest one is pensive wing. So Docker exec-it pensive wing sh. We do a Docker ps again. We should see one container running. We do, and then Docker logs, and this should say 1. Yes. So, all right, how do we surface the Docker and Docker depth? Let's exit out of our pod, close this split screen, and cancel out of our container. We'll go back here. I think to surface it, instead of redirecting all of this, we should just be able to run it, and then the logs should surface on their own. Let's find out. So let's build it again, run it again. There it is. Cool. All right. So this is spanning all the way back up. So we can now monitor our depth. I'm waiting for a 2. Give me a 2. Are we not going to get a 2? There it is. Cool. So now that we can see how deep our warren is, we need to next figure out our disk, CPU, and memory. So let's cancel out of this before I crash my computer. And because I don't need the raw data, and because I'm video capturing the mini PC anyway, I think what I might do is just run a number of commands from a shell script as a loop that monitors our IOPS, our inodes, our disk free, our memory free, and our CPU usage. Instead of writing a shell script to do it, because I'm recording the screen, I'll just open multiple terminals, and I'll use the watch command to watch df-i to see the free inodes. I'll do a watch command on df-P lowercase h to see the disk utilization. I'll run a watch command on free-m to see the memory usage, and then I'll also be running htop in another terminal. So I'll have multiple terminals open, I'll be recording the screen, we'll be capturing everything. So the next thing to do is to move all the work we've done so far onto the new computer. So that's easy enough. We'll switch back to the terminal here, and we'll cd one directory up, and we'll rsync-av our new directory to just my first name. The IP address is 192.168.1.205, and I'll just write it to /temp. All right, all the files are copied over, so I'll go ahead and SSH to the system now. And I don't want to mess with having to add my user to the Docker group or any of that nonsense. I'll just run everything as root. So I'll cp-r/temp/24, and I'll copy that to the local directory. And that should also change the ownership of everything to root. So if I do an ls-lah on the directory I just copied, yes, everything is owned by root. So now if I do docker ps, I shouldn't see anything. I'll do a -a for good measure. Excellent, everything's blank. And we want to do a docker build -t fishy. All right, and with that built, now what I need to do is on the mini PC, I need to get all my watch commands up and running. I need to hit record on the capture device, and then I need to run the actual docker run command. And then I'll probably fast forward through most of this, and we'll reconvene when I have results. All right, let's discuss what happened, because I did not see this coming. Maybe I could have, but I would have had to do a lot more research to recollect exactly how Docker works. So Docker is really just an illusion. You're not really inside of a container. You're inside of a Linux namespace, or your host operating system's namespace. And everything that looks like its own environment inside of a container is really just an isolated space within that namespace. And the reason why we're only getting down to 31, remember we're starting at 0, so we're actually getting to a depth of 32, is because we're creating a namespace and a namespace and a namespace and a namespace. And in one of the runs that I did, I actually used ls-ns --tree equals parent. That actually showed us the hierarchy of the namespaces being built out in a tree format. So at compile time of the kernel, that is a tuning parameter that is set. And I'm guessing that it's set to 32 for Debian. It's probably set for 32 for almost everything, because how often do you need 32 layers of abstraction on a namespace of a namespace of a namespace? Only people like me who are pushing the limits of Docker want something like that. So I think I know a workaround. I think there should be a flag in Docker to say, and I alluded to this earlier. Remember, you might recall how I said that I was told Docker and Docker is just talking to the parent system. Well, I think we have to do that deliberately. So let's find the flags for setting the host namespace or PID, or I'm not exactly sure what that's going to look like. I've got a guess, but let's figure out what we need to do to tell our Docker and Docker to actually use the parent-most Docker. All right, let's start with man Docker. I think memory serves, there's a --PID or something along those lines. If there is, it's not in the man page, which doesn't surprise me, because look at this man page. It doesn't offer a whole lot of insight. So let me do some research. If it ends up being more complicated than just a single flag, then I'll try to bring you along for the ride. Okay, I remembered exactly right. So after privileged, we're going to say --PID equals host. We'll save that. I'll get it moved on to the other machine, and we'll see what that run looks like. Okay, so it looks like the exact same thing happened again, but this time with networking. So I'm just going to do a little research. I'm going to figure out all the things that I need to set to host. I'm going to try again. All right, this is what I landed on. PID, host, network, host, IPC. Don't know what IPC is, but aside from the obvious, well, from what perspective is IPC obvious? I'll let you figure that out. And then UTS and C groups. So put everything on host, I guess. I don't know. We'll try it. We'll see what happens. And hopefully we'll make it past 51. That went poorly. Let's maybe just pare it back to just network host and PID host and see if we make it any further. All right, I think I was too hasty with adding this network equals host flag. I can't really get past a depth of 1 when I add it. So I've gone back to here, and this time I got a very different error. So I think what I have here is probably fine. Like I said, I think I was just too hasty to assume I needed all this other stuff. So I think what I'm going to do is to really make sure that Docker really is ready, because I think that might be the issue. So I'm going to say sleep, I don't know, let's say sleep 5. It's going to add a lot of extra time to the process, but where we're failing doesn't really make sense. And the error messages that I'm getting don't make sense because it's acting as though I'm trying to pull the container image from Docker Hub. Oh, you know what? I probably am, because I'm doing a Docker build every single time and I'm doing Docker and Docker. So the image isn't cached. So I wonder if I'm being rate limited by Docker Hub. So I'm going to see if there's any documentation around the maximum number of requests per second, per minute, whatever, that I can make against Docker Hub, and see if I can tune my sleeps to just extend past that. Okay, I'm reading a couple of things. I'm reading either I can make 10 pulls per hour to Docker Hub. That number doesn't make any sense because I've definitely exceeded that in the testing that I've done so far. So I'm much more inclined to believe the other number that I'm seeing, which is 100 pulls per hour. So I think what I'm going to do is over here in VS Code, I'm going to add a sleep 450 seconds. And I think that's going to pad things out long enough so that I'm not exceeding their thresholds. And also, I don't want to suppress the Docker build messages. Well, I do, but I want to limit how much I suppress them. I want to be able to see an error when it fails, but I also don't want to surface all the noise when it's building. So what I'm going to do is I'm going to change this Docker build command a little bit. Instead of directing to dev null, I'm going to redirect to temp build, both standard out and standard error. And then I'm going to say or, so if my Docker build fails, it's going to do this other thing. And then inside of curly braces, I'm going to cat temp build, and then exit 1. If I can type exit. So effectively, if we build successfully or not, we're going to write the build log to temp build. And if this exits with an error code, we're going to cat the file and then exit the application. This way we can surface what's actually going wrong with this process. I'm going to copy it over to the other host and we'll give this a shot. And hopefully we'll learn something in the process. Okay, so what just happened? I'm not sure. I have a hunch and I have a workaround. Let me bring up the error message here. So for the second time, we made it to a depth of 51, and I actually think that this is largely coincidental that we hit the same number both times. I think what's going on is that we've got so many layers of network address translation or NAT going with our nested Docker containers that we effectively are causing a timeout trying to reach the Docker registry. To recap, the first time we hit 51, this was the issue. I added the -- network equals host, and we only made it a couple layers. I removed that and added a sleep function so we're not hammering the Docker registry quite as hard. And we are back to a depth of 51 and a timeout reaching the Docker registry. Here's the game plan. You can package up a Docker container as a tarball. So I'm thinking something along the lines of make the tarball part of the Docker image so I don't have to pull it, it's already there. And then we should be able to get past this barrier of a depth of 51. So let's go back to our Docker file over in VS Code, and let's bundle the Jonah image into our image. We're getting real meta now. But first, before we can do anything in here, we need a tarball to package into here. So let's go ahead and build that first. So back to the terminal, and the Docker image should already be pulled onto the system. So let's double check. And yes, there it is. So let's package it up as a tar file. So we'll cd into our directory here. For my example, docker save repository, and then the image name, and then the tag, and then -o, and then let's name it jonah.tar. So now if we do an ls, we should see jonah.tar. We can bundle that into our Docker image now. We'll go back to VS Code, and we can copy our image into our containers. So copy jonah.tar to jonah.tar. And now in run me, we need to, my example here says Docker load. So yes, so we need to load the tar so that we're not pulling it every single time. So before our build here, we need to load Jonah from the tar file. So we'll put a comment in here, load devdol Jonah latest from the .tar file. The command to load it from the tar file should be docker load -I jonah.tar. And just to begin with, I don't want to suppress any output here because I want to know if this is going to work first. And then everything else should be the same still. So let's go ahead and test this locally. So back to my terminal, and we'll build it and we'll run it. And I'm going to let this run to a depth of about 2 or 3, or actually let me cancel this first because this sleep 450 is overly aggressive, I've decided. Since I was letting this run overnight, it was fine, but since I need a little bit faster of a turnaround, let's tighten up this timeline. 120 or 2 minutes. And this should keep us well within the threshold of pulling images, but actually we shouldn't be pulling any images anymore. So let's completely comment this out. We'll go ahead and build that and test it. Loaded image. So it looks like it's working great. Let's cancel this. We'll go back to our code here. We'll go ahead and remove this sleep. We're going to remove this code that we're no longer using. And I think we should be set. I feel like I'm missing something, but we'll go ahead and give this a shot and see what happens. So I'm going to rsync these files to the host system, and we will give this another go. even with preloading the Docker image with the base image, we still ended up only making it to level 51. So it must be that's phoning home regardless. I've done a little research and I think we can work around the issue. I think the way we do that is with an environment variable, and on the Docker build line right before it, go ahead and specify Docker build kit equals 0 and see how far we get. I forgot to redirect IO on Docker load, so let's suppress those messages while we are here. Oh, you know what else? I don't think that I ever... Let's check. Yeah, I never specified a work directory in here. Work dir... Oh, let's go with dind. Okay, let's see how far we get with this. Okay, 272. That seems to be the bottom of what Docker and Docker can do on that specific mini PC. So let's do a quick breakdown of what we're looking at from my screen recording. And the first thing that jumps out to me is that the CPU is just completely pegged. Like, we are using all of the CPU effectively. There's a little bit of leeway, but look at those load averages. Like, yikes. If this was a production system, we would be having problems. So not too surprisingly, we see a ton of Containerd and Dockerd instances running. And instead of looking at the output from free-m, let's stick with the output from htop to look at memory and swap, just because it's a little bit more comprehensive. And we are using a fair bit of memory, but we're not really using any of our swap. So we still have plenty of memory overhead, which again points back at the CPU being the real bottleneck, at least on this particular system. Moving on to the inodes, my prediction was way off here. Like, we hardly even touched the inodes. I think we started at 4 or 5% and we landed on 6%. Like, our inode usage was very, very small. We still had plenty of overhead in terms of the number of inodes on the host. But we did end up using a considerable amount of disk space. If we had a more powerful CPU, or if we had more CPU cores, I think the next hurdle would have been our disk usage, because we started around 38% usage. And by the end of our final run, we landed on 87% usage. So we were creeping up. And if we hadn't been blocked by the CPU, we would have hit a roadblock with our disk capacity. Well, thanks for sticking with me on this video. It was a long one. It took me a while to record this one. It was multiple days, but it was a good time. If you're still with me, thank you. Maybe leave a comment down below. I don't know, mention something or other about the walruses. If you have an idea for how I should abuse some other system, leave it down in the comments. I'm always up for new ideas. I've got a couple of home lab videos that I'm working on, and a couple of other ideas in the pipeline I want to be a lot more regular about uploading in 2026. I'm currently unemployed and I'd love to make this my job, so if you can like, comment, and subscribe, help me out, that'd be amazing of you. But in the meantime, you'll catch me in the next one.